John Coltrane, legendary jazz saxophonist, came up with this system for arranging the circle of fifths in a different way, essentially. So it consists of two concentric circles in which the large notes here are the zigzagging across are the circle of fifths / circle of fourths, depending on which way you're going around. And then across from each large note, there's 4 notes that are arranged in whole steps. So as you go around each concentric circle, it's a scale of whole steps. And like the inside one is one of the whole step scales and the outside one is the other whole step scale. We took a quarter of the Coltrane Circle as it's drawn here and turned it into an interface. 15 buttons. Each button has a force sensing resistor under it, and the buttons are made of silicone that are on top of a piece of acrylic, and I can just pull it up to show what it looks like under there. And then on top, we have a soft pot, a soft potentiometer that controls your place in the circle. So that's just a C right now. And then as you move through it, you can get different notes. So it's basically moving your pie slice around the circle so that you can get any portion of the circle at any time. These 3 buttons control playing chords. Each button adds a different note on top of the large 3 buttons. If I tap this button once, it adds a major third. If I tap it a second again, it's a minor third. And then if I tap this one, it adds a perfect fifth. And then this one adds a major seventh or a minor seventh. So doing that, you can get any combination of triads that you want.
So the whole thing's pretty much powered by an Arduino that does all the data collection underneath it.
There's our Arduino. It's wired up to this breadboard that has one of them fell out. That's okay.
It constantly samples all the sensors and ships it off to max. 1 note for each FSR. So it does do polyphonic aftertouch across, how many do we have? 15?
There's 15, so.
Across 15 channels. And then various other little gadgets to do the interval changing and the chord changing. And then that runs into Reason with 15 subtractor modules holding an FSR. Pressing more after you play increases the filter cutoff, so you get this, you have expression after you press the note.
And you can do that independently.
We get LED feedback, so you can kind of have a sense of what's going on, because it is a little bit difficult with everything being translucent, so having some visual feedback is nice. Since you can change what the interface is actually doing, it helps to have some visual feedback.
If you press one of the buttons, a corresponding light will light up. And then we have 3 special notes just to kind of help you figure out where you are. So we have like a couple colors that help you figure out where you are in the instrument. So if you press down on C, it'll light up blue. F will be this like magenta color, and G will be this orange color.
Basically, anytime you play a C anywhere in the instrument, it'll be the same color, no matter where you move in the soft pot.
So that's a C, that's more blue. That's an F. And then if we move it around, if you play F again, wherever you're playing, it'll light up that color. If we had more time, we'd probably come up with like a color scheme for all the notes.
That was a time constraint for sure.
Yeah.
I think one of our original ideas was that when you move your finger around the soft pot, the lights light up to give you a reference as to where you are as you're moving it, so that like before you start playing, you know where you are.
If we had more time.
That's the time constraint.
We were sending like controller information constantly for each of the 15 sensors. And we also add like a smoothing function to it to try to like smooth out the notes. And so there was just so much MIDI data being sent that something along the minibus just like stopped, so it wasn't actually leaving max. And so things would just get stuck for 20 seconds on end. There are a strip of LEDs where each LED has its own chip on it. And what you can do is actually feed it data and tell it which color you want it to be. It's PWM pulse width modulation data. So basically just like a bunch of ones and zeros. Another thing, more of a design challenge, was figuring out exactly how to design this thing. We spent a lot of time discussing like what the shape would be, how large it would be.
One of the things that we like noticed was that, or that other people have even commented on, is that it seems like it wouldn't make as much sense to have it curved like a smile instead of like a frown, because it looks like your hands might sit better if it was an upward curve, but actually like if you put your hands on it, you'd have to like have the palms of your hand kind of touching each other. So we figured it was a better way to lay it out like that. So, and we did incorporate a bit of a tilt so that it's more comfortable to play, so that you're not just playing a flat surface. These notes are all like even offsets from the big middle note, and these are all odd offsets going up to the right and down to the left. And wherever you move your pie slice, basically, it's always the same relationships, but just different notes for all of them. And the math for that is done by just reading the soft pat value, and then basically every section was mapped to just like a distinct like plus or minus value that moves it to the next note in the circle of fifths.
I don't know if everyone's familiar with Coltrane changes, but he has like the giant steps modality of modulating between keys like many times in one song. And this, because you have two whole tone scales that are sort of overlaid, you can modulate between your usual modes much more quickly. At least that appears to be the idea behind the circle. And we haven't really developed a technique for that yet, since we haven't mastered the instrument totally. But it does seem to have, like, just with one hand you can play some really interesting jazz melodies, just sort of straight up. It's a little bit more difficult to play more traditional melodies, though.